Hello students, my name is wasi anjum. I teach NEET aspirants zoology. Today my topic is oxygen dissociation curve. So this is my topic today, oxygen dissociation curve. You know that the oxygen has affinity to bind with hemoglobin and it makes the molecule oxyhemoglobin. Oxyhemoglobin is formed when oxygen combines hemoglobin, and this process is called association of oxygen with hemoglobin. The reverse is called dissociation. So this is association and this is dissociation. Now, what are the factors which are responsible or which are the factors responsible for this association and dissociation of oxygen with hemoglobin? So the factor responsible are four. There are four factors. So these factors are, the first factor being oxygen or partial pressure of oxygen. Second factor being carbon dioxide or partial pressure of carbon dioxide. So the first factor is partial pressure of oxygen, and the second factor is partial pressure of carbon dioxide. Third factor being hydrogen ion concentration, and the fourth factor is temperature. Now, what are the conditions, favorable conditions favorable to association, and what are the conditions related with these four factors favorable to dissociation? So let us discuss it one by one. The first factor, and now let us also discuss what are the partial pressures. If there are a mixture of gases, then the contribution of the individual gases to the whole pressure is called partial pressure of that particular gas. So here, in blood, the combination of a mixture of oxygen and carbon dioxide, so their respective partial pressures can affect into the association and dissociation of oxygen with hemoglobin. So the first factor, PO2, if partial pressure is more, if partial pressure of oxygen is more, then this more reactant will lead to more formation of oxyhemoglobin or association reactions. So increased partial pressure of O2 is a factor favorable for association. Then, if partial pressure of oxygen is more, naturally partial pressure of the second gas will be low and favorable for association of oxygen with hemoglobin. And as we know that this carbon dioxide is dissolves with water and forms H2CO3, which further dissociates into hydrogen ions and bicarbonate ions. So if carbon dioxide is more, that means hydrogen ion is more, made from the dissociation of H2SO3 made after the dissolution of carbon dioxide with water. So it is equivalent, more CO2, more hydrogen ion. And similarly, the more hydrogen ion or less hydrogen ion will be a favorable condition for the association reaction, and as is the case evident with also PeCO2. So these are the equivalent factors, PeCO2 and hydrogen ion. The last factor being temperature. That temperature will lead to high temperature will lead to dissociation of oxygen with hemoglobin, because that temperature, increased temperature, will give the kinetic energy to oxygen and that will dissociate. So low temperature is the favorable condition for association. So these three factors are actually interfering factors with association, and this is the promoting factor for association. The reverse is the condition here when we discuss the condition favorable to dissociation. Here it was increased oxygen, here it is decreased oxygen, it is interfering, and these three factors were lesser for the association condition, and here it will be reversed. More conditions of these three factors will be responsible for dissociation. So this is what we have learned from this table. That means PO2 is more and these three factors is less, the condition is favorable to association, and if the PO2 is less and these three factors are more, that means conditions favorable for dissociation. So mainly we can say here that increased partial pressure of O2 will lead to association, and decreased partial pressure of O2 will lead to dissociation. One another conclusion can be made from this, that if the partial pressure is decreasing, if partial pressure is decreasing, partial pressure of oxygen is decreasing, that will lead to dissociation. So this condition can be concluded. These facts can conclude this fact. We can conclude that dissociation can be favored by decreasing partial pressure of oxygen, and this is the basis for the drawing of oxygen dissociation curve. That we can understand better while drawing the dissociation curve, oxygen dissociation curve. So oxygen dissociation curve is S-shaped. That S-shaped oxygen dissociation curve is like this. So this curve is oxygen dissociation curve. Oxygen dissociation curve. Here in oxygen dissociation curve, on x-axis we draw the partial pressure of oxygen. So increasing partial pressure of oxygen on x-axis from origin towards the x-axis, and from origin towards the y-axis it is the percentage saturation of hemoglobin with oxygen. So here it is 0, 20, 40, 60, 80%, and then saturation, that means 100%. And here the partial pressure in mm of Hg, 20, 40, 60, 80, and 100 and 120 mm of Hg. So what we can see here is that this S shape, there is a slow and then accelerated phase of this saturation and then plateau or saturation. So we can draw 2 points here, point A here and point B here, and extrapolate it at these 2 points. What we can see here, as we go from A to B, the partial pressure of oxygen decreases, and that leads to the, on y-axis, leads to the dissociation or lesser saturation percentage of oxygen. So oxygen becomes less saturated, that means oxygen is dissociating. Less saturation is dissociation, less availability or dissociation of oxygen. So from A to B, if we decrease the partial pressure of oxygen, that leads to dissociation. And this is the basis of calling it as an oxygen dissociation curve. Now we draw 2 more things related with this, is that right shift or left shift. So for right shift we discuss first, this is the at the same partial pressure from A to B curve, at the same partial pressure. The saturation goes down, that means dissociation happens. So this is dissociation, and this dissociation is when we go from the normal curve to the right shift, that is here on this graph, which is graph B, or right shift of the curve, right shift of the graph. Shift from the normal curve to the right side, and this is dissociation happening at the same partial pressure of oxygen. And if we talk about this curve C, small c, at the same partial pressure we have to go up to the C to reach C, from A to C, from normal curve A to the right to the left shift C curve. So that means the saturation is increasing, and this increased saturation means association. Association happens in the lungs or alveoli, and dissociation happens at tissue level, and this is at alveoli level. This right shift from A to B is also having a favorable condition, that is 2,3 biphosphoglyseric acid. Biphosphoglyseric acid 2,3 is a favorable condition for right shift. Now the other favorable conditions for dissociation and association we have already discussed, and we can recap it as in the case of association, the favorable conditions will be increased partial pressure of oxygen and decreased partial pressure of carbon dioxide and decreased hydrogen ion concentration and decreased temperature. While in the case of dissociation, that means right shift, this is the right shift and this is the left shift. From A to B is the right shift and B to C is the left shift. So when we talk about this right shift or dissociation, we can say that the favorable conditions are decreased oxygen concentration and increased oxygen partial pressure and increased carbon dioxide partial pressure and increased hydrogen ion concentration and increased temperature. So these were the things we have to discuss about oxygen dissociation curve. So for getting some more informative channels, lectures, you have to subscribe wasi anjum channel, and thank you for watching.